In this video, I am going to find the inverse of the function f of x. Once I find the inverse, I am going to show that this inverse is in fact the inverse of the given function by doing function composition in both directions. There is a standard process for finding the inverse of a given function. What we do here is we take the given function, which is this, we set it equal to y first, and then we solve for x. Now, in order to solve for x in this equation, what I am going to do, I am going to multiply both sides of the equation by 5 so that I can get rid of the denominator 5. So on the left hand side I have 5 times y, that is 5y. On the right hand side, this 5 and this 5 cancel out, that leaves me with negative 3x in the first term, and in the second term 2 times 5 is 10. Now I need to solve for x. To solve for x, I just subtract 10 from both sides. So subtract 10. If I do that, I get 5y minus 10 is equal to negative 3x. Then I can divide both sides by negative 3. Divide both sides by negative 3. That's going to give me 5y minus 10 over negative 3 is equal to x, because negative 3 and negative 3 is going to cancel out here, which by the way is the same as x is equal to. Now there is a negative 3 in the denominator here. I'm just going to multiply the numerator and denominator by negative 1 to get negative 5y plus 10 on the top, and on the bottom is just 3. Now at this point, what we do in order to find the inverse function, we actually switch the x's and y's. So this y is going to become x and this x is going to become y. If I do that, I get the following. Is going to be y is equal to negative 5x plus 10 divided by 3. So this function, by the way, I am claiming to be my inverse function, which I will call f inverse of x. F inverse of x. Now, how do I show that the function I got, f inverse of x, is in fact the inverse of this given function? There is a standard way to show that involves finding the function composition. We need to find f composed with f inverse of x, and then we also need to find f inverse composed with f of x. We need to find function composition in both directions. If in both directions we find that the function composition yields x, that means that the function I found is in fact the inverse. So that means what we are expecting, that this should be equal to x and this should be equal to x. Regardless of the direction of the composition, it should give us x. So let's check that out. Note that f composed with f inverse of x, by definition that is going to be f of f inverse of x. That's the definition of function composition. Now f of, what is f inverse of x? I just found it right here. Negative 5x plus 10 divided by 3. So this goes into the function as an input, negative 5x plus 10 divided by 3. This is just one value, you can think of it. Don't break it down. Don't think that it's negative 5x plus 10 and then maybe divided by 3, something like that. It's just one single unit. This whole thing is an input to this function. Now what does f do to the input? We can look at the definition of f here. It takes the input and multiplies it by negative 3 over 5 and adds 2 to it. So this function is going to do exactly the same thing. So negative 3 over 5 times the input. Input is negative 5x plus 10 divided by 3. So that's this times the input x. Then I need to add 2 to it. Now note that there will be some cancellations taking place here. This 3 and this 3 is going to cancel out. Then you're going to have negative. Don't forget about this negative. If I distribute it, it's going to be negative times negative 5x is going to be positive 5x. Then negative times 10 is negative 10. Negative 1 times 10, negative 10. Divided by 5 and then plus 2, these two. Then I can just break it down further. 5x over 5 minus 10 over 5. So I break it down into 2, then plus 2. 5 and 5 cancel out. That gives me x minus 5 goes into 10 twice. So negative 2, then plus 2, which gives me x, because these positive 2 and negative 2 cancel out. So this one checks. Now I've got to do the exact same thing for the other one. So this one. So let's do that one. So f inverse composed with f of x. By definition, it is f inverse of f of x. Now I'm just going to plug in the f of x here, which is going to be f inverse of, remember f of x is given here, which is this negative 3 over 5x plus 2. Now think of this whole thing as an input going into f inverse. Now I know what is f inverse. I have it right here, which is negative 5 times the input. Okay, negative 5 times the input plus 10 divided by 3 is going to do the exact same thing. Negative 5 times the input, which is negative 3 over 5x plus 2. Then with that it is going to add 10, which is this value, and divide the whole thing by 3. Now there will be some cancellations taking place here. So I'm just going to distribute this negative 5. So it's going to be negative 5 times negative 3 over 5x, which is going to be just a positive value. Negative 5 times 2 is negative 10 plus this 10, the whole thing divided by 3. Now these 5 cancel out. Negative and negative is going to make it positive, so it's going to be 3x on the top, and then negative 10 positive 10 cancel out, and in the bottom is going to be 3, which is just x. So this one also checks. We did composition in both directions, f composed f inverse of x and f inverse composed f of x. In both directions we got x. That means the function we found right here, which is, let me write it down here again, this is in fact the inverse of this given function. Now let's talk about an interesting property of inverse functions. So this is the given function f of x, which kind of looks like this. It goes to the point 2. So this is a sketch, so don't assume anything. So it kind of looks like this, okay? And the new function we found this, that one, by the way, kind of looks like this, which is more like this. Now this is what you want to do. You want to draw a line y is equal to x. So I'm going to just use dash. This is my y is equal to x. This sketch is not perfect. However, this should give you an idea. Symmetry, inverse functions are reflections of each other about the line y is equal to x. This yellow line and the green line, they are actually reflections of each other about this line y is equal to x. Remember, y is equal to x goes right through the middle. This is 45-degree angle, this is 45 degree, and this is 45-degree angle. So always if two functions are inverses of each other, they are going to be reflections of each other about the line y is equal to x. So this is an important feature. So you kind of can see it here that if you think of the line y is equal to x as a mirror, so these two guys are the reflections of these two guys. That's what it is. So that's the important feature that you wanna keep in mind. So let me summarize. It's a long video, but still it covers a lot of concepts. To find the inverse, what we need to do is this. We need to first set the given function to y and solve for x. And then we switch the x and y's to get the inverse function. So this is, we claim it to be inverse function. Then once we find that, find this function, we need to do function composition in both directions, and in both directions we should get x to ensure that the function we got is in fact the inverse. So which we do here. Now finally, if two functions are inverses of each other, they are the mirror images of each other or reflections of each other about the line y is equal to x. I hope that this discussion was helpful. Thank you very much.